stress is equal to force upon area. It is measured in Newton per meter square. Then if you consider body is in the form of wire, and if you fix one end of wire to the rigid support and second end is loaded by weight or load, then elongation of wire takes place, and the corresponding, that is length of body changes, then the corresponding stress is called as a tensile stress, and tensile stress is given by the equation tensile stress is equal to applied force divided by cross sectional area of wire. Then when the body is three dimensional in nature, when you apply the external force, then volume of body changes and corresponding stress is called as volume stress. It is measured in Newton per meter square, which is equal to F upon A. When you apply tangential force on a body which is in the form of sheet having a particular area, due to tangential force lateral displacement of body takes place, and due to lateral displacement shape of body changes and shearing stress or tangential stress is produced. It is again measured in Newton per meter square. In this figure, this is the original position of the body. When the tangential force is applied on upper layer, an upper layer is called as lateral layer, and lateral displacement of body takes place and shape of body changes. This is called as the lateral angle. This delta L, small delta L, is called as the lateral displacement. Then such type of change in shape which is produced due to the tangential force, therefore the corresponding stress is called as the tangential stress or shearing stress. Then strain is a ratio of change in dimension of a body to the original dimension. Again, as per the dimensions, there are three types of the strain: longitudinal strain or tensile strain, volume strain, and shearing strain. If the body is in the form of wire, and length of body or length of wire changes under external load or force, then longitudinal strain or tensile strain is equal to change in length divided by original length. It is a ratio of same type of quantity, therefore this longitudinal strain or tensile strain has no particular unit. Then volume strain is nothing but change in volume divided by original volume. Shearing strain is nothing but lateral displacement of, it is a ratio of lateral displacement of a body to the displacement of a lateral layer from fixed layer. Then in case of all types of strain, there is no unit because it is a ratio of same type of quantity, physical quantities. Then Hooke's law: within elastic limits, stress is directly proportional to the strain. Therefore stress is equal to constant into strain, or stress divided by strain is equal to constant. This is called as a, this constant is called as the modulus of elasticity. Stress is directly proportional to strain within elastic limit only, and above the elastic limit graph is not straight line. This is called as the plastic region. Then there are three types of the modulus of elasticity: Young's modulus, bulk modulus, and modulus of rigidity. First type of stress is a tensile stress divided by tensile strain. This ratio is called as Young's modulus. It is the ratio of tensile stress to the tensile strain within elastic limit. Therefore y is equal to tensile stress upon tensile strain, F upon A upon small l by capital L. Therefore y is equal to F into capital L will be at a numerator, small l into capital A. Therefore y is equal to F is nothing but m into g, L divided by pi r square into small l. Therefore y is equal to m into g into capital L divided by pi r square into small l is called as Young's modulus. Then bulk modulus is equal to volume stress divided by volume strain. Volume stress is nothing but force upon area. Volume strain is nothing but change in volume divided by original volume. Therefore k is equal to F into V divided by dV into A. But force divided by area is equal to pressure into volume divided by change in volume. Bulk modulus is denoted by K. Modulus of rigidity is a ratio of shearing stress to the shearing strain. Shearing stress is nothing but F upon A. Shearing strain is nothing but lateral displacement upon distance between lateral layer and fixed layer, that is tan theta. If theta is a lateral angle, then tan theta is called as a lateral. Tangent of lateral angle is called as a shearing strain. Therefore F upon A tan theta. Therefore relation between Young's modulus, bulk modulus, and modulus of rigidity: Young's modulus is equal to 9 into modulus of rigidity into bulk modulus divided by 3 into bulk modulus plus eta is nothing but modulus of rigidity, 9 eta k divided by 3 k plus eta. Then we will see about the stress strain curve. If you plot a graph of stress versus strain by increasing load step by step, stress increases step by step, strain also increases. Stress and strain both are increasing directly proportional to each other. Graph is straight line. Hooke's law is valid or obeyed. If you increase the stress above the elastic limit, then small increase in stress produces major change in strain. There is one point is called the yield point, from which stress without increase in stress, strain is increasing rapidly. That is called a yield point. Then if you remove the external load above the elastic limit, then wire cannot regain its original position. There will be permanent deformation takes place. If you increase the load step by step, we will come across ultimate point. Ultimate point is the point which represents the maximum or extreme capacity of wire to bear external load, and if we increase the load above the ultimate point, then diameter of wire starts decreasing and wire breaks at a particular one point, is called as the breaking point. These are the different points are there. Then if we apply the load below the ultimate point, then the wire will be in a safe zone. Therefore factor of safety is equal to ultimate stress divided by working stress. Working stress means below the ultimate point. Factor of safety, wire is safe in the use, therefore factor of safety can be defined as it is a ratio of ultimate stress to the working stress below the ultimate point, ultimate stress to the working stress, that is called as a factor of safety. Then we'll see, if when you apply external load on a wire, then length of wire changes, means diameter also changing, length of wire increases and diameter decreases. Then Poisson's ratio, it is a ratio of lateral strain to the longitudinal strain within elastic limit. Therefore Poisson's ratio sigma equal to lateral strain divided by longitudinal strain. Lateral strain is nothing but change in diameter divided by original diameter, divided by longitudinal strain is nothing but tensile strain, change in length divided by original length. Now we are going towards the first one problem. Read this problem carefully. First one, what is given in this example? A wire of diameter 4 mm and length 2 meter extends by 2 mm by applying a force of 10 Newton. Find Young's modulus of a material of the wire. Now what is given? First sentence, a wire of diameter 4 mm. What is given? Diameter of wire equal to 4 mm. In SI system, we have to convert that millimeter into meter, and you know 1 millimeter is equal to 10 to the power minus 3 meter, because 1 centimeter is equal to 10 mm, 1 meter is equal to, one can say 100 centimeter, and 100 centimeter means 1000 mm, that is 1000 mm is 10 to the power 3, and when you have to convert 1 mm into meter, means I can say 1 meter is equal to 1000 mm, that is 1 mm is equal to 10 to the power minus 3 meter. That means when you are going to convert millimeter into meter, multiply by 10 to the power minus 3. Therefore diameter of wire is 4 mm equal to 4 into 10 to the power minus 3 meter, and length 2 meter, original length capital L is equal to 2 meter, extends by 2 mm, that is elongation is given, extension of length is denoted by small l or E, which is 2 mm is equal to 2 into 10 to the power minus 3 meter. Find Young's modulus of a material. We have to find Young's modulus when external force is 10 Newton. That means you can see a wire of diameter 4 mm, therefore radius is half of the diameter. 4 mm is diameter, therefore radius is 2 mm. 2 mm is nothing but 2 into 10 to the power minus 3 meter. Original length is 2 meter, elongation is 2 mm, and external force is 10 Newton. Whatever the quantities are given in the example, we have to write properly in a sequence. Then we have to write what we have to find. We have to find Young's modulus, and you know Young's modulus is a ratio of stress, tensile stress divided by tensile strain. Here strain is nothing but change in length divided by original length, stress is nothing but force upon area. Therefore Young's modulus is equal to y is equal to f upon pi r square divided by small l by capital L or elongation E by capital L. You can take either one of the notations for this. Then f into L divided by small l or E into pi r square, this equation. Then put f is nothing but f is equal to 10 into original length is 2 divided by extension or elongation, extension of in the length is 2 mm, that is 2 into 10 to the power minus 3 into pi 3.142 into r square, radius of wire 2 into 10 to the power minus 3. Put all the values in meter, that means we have to use the SI system of the units. Then put all these values, f is 10, 2 is the original length divided by elongation 2 into 10 to the power minus 3, radius pi r square means pi is 3.14, r square 2 into 10 to the power minus 3 bracket square. Then 10 into 2 20 divided by 2 into 3.14 into 2, you can take product of all these 3, 10 to the power minus 3 into 10 to the power minus 3 square, 10 to the power minus 6 into 10 to the power minus 3, 10 to the power minus 9. Then if you take the ratio of 10 into 2 20 divided by 3.14 into 2 into 2, 2 into 2 4 into 3, that is 12.56. 20 divided by 12.56 means 0.795 into 10 to the power minus 9. If you transfer to the numerator, it will be plus 9. Then final answer is 0.795 into 10 to the power plus 9, and Young's modulus, unit of stress, Newton per meter square. Therefore Young's modulus of a wire is 0.795 into 10 to the power 9 Newton per meter square. That means in this example, a wire of diameter 4 mm and length 2 meter, radius 2 mm, on which external applied force is 10 Newton, and you have to find the Young's modulus. You can find Young's modulus is equal to stress by strain, that is y is equal to mgl divided by pi r square into small l. Otherwise you can say mg is nothing but force. In this problem direct force is given. Sometime question may be asked in which weight will be given, or sometime mass will be given. If mass is given, then it will be suppose 5 kg or 2 kg. Then m is given. You have to multiply by g. M into g. G is 9.81 meter per second square. Then you will get force. Force is nothing but weight. Weight is nothing but m into g. But in this problem, in this numerical, direct 10 Newton force is given. Therefore, we can write F into L divided by elongation into pi r square area, and you can find the Young's modulus. Similarly, you can see the second example in which a longitudinal stress of 8 into 10 to the power 7 Newton per meter square is produced an extension of 1 mm in a wire of length 2 meter. What is given? Stress is given 8 into 10 to the power 7 Newton per meter square. Stress is given and produces extension of 1 mm, that is elongation extension equal to 1 mm is equal to 10 to the power minus 3 meter of a wire of length 2 meter. Original length of wire 2 meter. Find Young's modulus. Simple. Young's modulus is equal to stress divided by strain. Stress divided by stress is directly given, and strain is nothing but elongation divided by original length, change in length divided by original length. Therefore stress is equal to 8 into 10 to the power 7, is it, into this is the denominator of denominator, capital L will go up and small l will be, or elongation will be at a denominator. Therefore 8 into 10 to the power 7 into original length is 2 divided by elongation is 10 to the power minus 3. You can put here. Then what will get? 8 into 2, 16. 10 to the power 7, and then this is a 10 to the power minus 3 at a denominator. If you transfer this 10 to the power 3 at a numerator, it will be plus. Then 10 to the power 7 into 10 to the power plus 3. Base is the same. Therefore add the 7 plus 3, that is 10. That is 8 into 2, 16 into 10 to the power 10 Newton per meter square. Therefore Young's modulus is equal to 16 into 10 to the power 10 Newton per meter square. Means in this example, direct stress is given, elongation is given, original length is given, and you have to find the Young's modulus. Young's modulus is equal to stress divided by strain. Stress is directly given, strain is nothing but elongation divided by original length. Therefore original length divided by elongation. Therefore put the values and you will get the Young's modulus. Now proceed to a third one example. In this example, a wire of diameter 2 mm and length 2.5 meter mm extends by 1.5 mm, applying a force of 15 Newton. Find Young's modulus. Now what is given? Diameter of wire is 2 mm. 2 mm is equal to 2 into 10 to the power minus 3 meter. Radius of wire is 1 mm, which is also given, which is equal to 1 into 10 to the power minus 3. Original length 2.5 meter, which is also given. Here instead of mm we have to read as a meter, original length. Then extension is 1.5 mm, therefore 1.5 into 10 to the power minus 3 meter. External force is 15 Newton. You have to find Young's modulus. Same process. Young's modulus is equal to stress by strain. Stress is nothing but force upon the area. Strain is equal to elongation divided by original length. Therefore F into L divided by E into pi r square. F into L divided by elongation into pi into r square. Put all the values, we'll get the value of Young's modulus. In this way you can solve the examples of same nature in which you have to use the formula Young's modulus y is equal to mgl divided by pi r square into small l. Otherwise F into L divided by E into pi r square. And if other quantities are given and you have to find one of the physical parameters, you can find just by performing the mathematical operations on this. This is the end of this chapter. Thank you. If you have any doubt, you can ask from your side in this chapter elasticity. In second session we are going to study the most important chapter, that is thermal properties of matter, which one is again most important chapter for the mechanical engineering and civil engineering also. Thermal properties of matter. But this elasticity chapter is over. We have tried to cover all theory content as well as we have solved few examples. Similarly you can solve the exercise from this chapter. Read that example carefully, write the given quantities, write the what we have to find, use the according to basis of the given quantities, use the proper formula, put the values, use SI system, put the values, use your calcine scientific mode, operate the calcine scientific mode, perform the calculations of numerator, perform the calculations of denominator, and finally numerator divide by denominator, use bracket, and solve this numericals very carefully. You will get Young's modulus properly. Then if you have any doubt or any type of query, you can ask from your side in this topic. This is the end of first session. During second session, we will try to cover the next one chapter, that is thermal properties of matter. For any doubt, ask without any hesitation. That means basically elasticity is most important property of solid, in which when you apply the external force, body changes or deformation of body takes place, and when you remove the external force, body regains its originality. Then we have studied about the stress, type of stresses, strain, types of strains, then modulus of rigidity, Hooke's law, stress strain curve, and we have solved the numericals based on the different mathematical equations in this chapter. And in MSBT examination, problems of the same type will be asked, and you have to put we have to write all the given quantities, we have to write all what we have to find, convert that quantity into SI unit. That means if area is there, then it will be in meter square, elongation in meter, original length will be in meter, diameter, from the diameter to find the radius is half of the diameter, convert into the meter by multiplying, if it is in mm, multiply by 10 to the power minus 3, convert that into meter, put all values properly into the formula, then see what we have to find. If Young's modulus is equal to stress by strain, then stress is nothing but F upon A, strain is nothing but small l by capital L, then final equation M into G into L divided by pi r square into small l. Put the values, solve numerator separately, solve denominator separately, and solve very carefully, you will get the answer. Okay, I hope you have understood this session very properly, and if there is no question from your side, then we will meet for second session after 10 minutes break, and in second session we will study about the thermal properties of matter. Thank you.